In this example, we have two automobiles that crash into each other. And the key here is that they become stuck together, which is what that is trying to tell us. So this actually makes it a little bit easier when we're solving for final momentum. So initially what we're going to have is m1 v1 plus m2 v2. That's going to be equal to, since the two cars come together, m1 plus m2. And they're only going to have one velocity. We're just going to call it v prime because, again, it's just one object. So instead of solving for v1 prime and v2 prime, it's just v prime because they're going to be exactly the same. So we can actually start to plug stuff in right away and rearrange our equation a little bit so we get something that will be a little bit easier to work with. So m1, 2,000 kilograms, v1, 24.0 meters per second, east 20 degrees north. And this is important because we're going to keep everything written in here instead of breaking it up into components. And you'll see why when we get towards the end. So that's the first portion. Plus the second portion, 3,600 kilograms times 10 meters per second south, 40 degrees east, equal to m1 plus m2. So that's 2,000 plus 3,600. 5,600 kilograms times v primed. So on its surface, it doesn't look like we've done much, and it looks like we need to actually put these into component values to solve for them. However, if I divide both sides by 5,600 kilograms, and recall that the direction of the momentum is the same as the direction of the velocity. So I can just multiply mass times velocity to find momentum, and then get an answer where the direction is the same. Okay. Now, of course, these kilograms are going to cancel. So I'm going to end up with a value of meters per second plus meters per second. So if I do 2,000 times 24 divided by 5,600, what I'm left with is 8.57 meters per second. I'm going to move that over a little bit here. Let's try again. So 8.57 meters per second include the same direction as before, east 20 degrees north, plus 3,600 times 10 divided by 5,600, 6.43 meters per second south, 40 degrees east. That's equal to my v prime, because of course this cancels out. This again is just an exercise in vector addition. I've got one vector plus another vector gives me my resultant. So I can draw this pretty easily. So what you're left with here is your first vector, something like this. This is east 20 degrees north, and that's 8.57 meters per second. The second vector is going south 40 degrees east. So perhaps it looks something like this. 6.43 meters per second. So this here is 40. And then we have our resultant vector, which may or may not actually be perfectly flat. I know I've kind of drawn my picture that way, but that's not necessarily the case. So don't assume that that's a 90-degree angle, because it might not be. So I'll just exaggerate that a little bit by showing that this is 20 degrees. This is my v prime. If I know that this angle down here is 20, then of course this angle up here has to be 70, which then gives me a giant angle here of 110, which is going to be very useful for the next step, which is going to be to use the cosine law. So if this is the triangle that represents our vector addition, then we can just make use of the cosine law, which is going to say that v prime is equal to one side squared, so we'll pick and I'm going to ignore units just to make sure it can all fit, plus the other side squared, 6.43, minus 2 times the first side, 8.57, times the second side, 6.43, times the cosine of the angle across from the side we're looking for. So that is 110 degrees. If you put that all into a calculator, what you're left with is 12.3 meters per second. But of course, this is a vector, so we do need some sort of direction. To solve for direction, we're going to be looking for this tiny angle down here, but this is going to take two parts. So part one is going to be the sine law. So sine theta over 6.43, because that's going to give me this entire side here, is equal to sine 110 over the side we just solved for, 12.3. This leaves us with a value for theta of 29 degrees. However, that's not actually what we want. We're looking for this tiny angle in here, which I guess we'll call alpha. So our angle alpha is equal to 29, the entire angle that we just solved for, minus 20, the angle of the inside. So that's 9 degrees east, 9 degrees um, south, because of course I've drawn my kind of diagram a little bit wonky here. But because that angle is greater than the 20, of course it's got to be pointing in the southward direction. So this leaves me with east 9 degrees south, even though that's not quite what my diagram shows, but it's just because my diagram's a little bit off.